Hello everyone, in this video let's discuss about the summing amplifiers. In summing amplifiers, first we will discuss about inverting summing amplifiers. So if you are new to our channel, please subscribe for more engineering related topics. These summing amplifiers will sum more than one inputs, that is if you give the voltage wave as an input, more than one voltage wave, then they will sum and give the output. So if more than one input applied to any terminal of an operational amplifier that is opamp, output will be sum of the inputs. So output will be sum of inputs. Therefore let's consider two inputs, that is V1 and V2. Let's consider V1 and V2. So therefore there will be the resistance because of voltage, that is resistance 1, resistance 2, and because of voltage 1 and resistance 1 there will be the production of current, that is I1. Next, this because of V2 and R2 there will be the correct production of current, that is I2. So both I1 and I2 will combine right here, they will form a total current I. This current will flow across the feedback circuit also. The same current will flow up to Vout, that is up to output voltage. We are giving the input to the negative terminal, so it will be inverting, because negative terminal of an operational amplifier means inverting terminal. Now let's refer this resistance as RF, that is feedback resistance RF. Now we also know that the voltage across the negative terminal VA and the positive terminal VB will be equal. Therefore VA is equal to VB. And we also know that VB is grounded. As VB is grounded, VB value will be equal to 0. As VB value will be equal to 0, VA equal to VB equal to 0. Both VA and VB, that is the voltage across the inverting and non-inverting terminal of an operational amplifier, will become 0. Now let's compute the equations, that is input side equation and output side equation, that is including the feedback circuit, to get the value of output voltage. So now first let's design the input end. At the input end, that is including from V1 V2 to VA, that is the negative terminal where we are giving the input, up to that we will consider as the input end. So the current will be same, that is current I. What is current I? I is equal to I1 plus I2. So from Ohm's law we know that V is equal to IR. Therefore what will be the formula for I? That is current is equal to voltage divided by resistance. Now let's find out the value of I1, then I2. So what will be the value of I1? I1 is flowing because of current. I1 is flowing because of voltage V1 and resistance R1. Therefore I1 is because of voltage V1 and it is flowing from V1 towards VA. Therefore V1 minus VA divided by, what is the resistance in between them? R1. So R1. We also know the value of VA. So VA is equal to VB is equal to 0. Therefore its value will be equal to 0. V1 by R1. What is the value of I1? I1 is equal to V1 by R1. Next I2. So I2 is equal to, I2 is flowing from V2 towards VA. So V2 minus VA divided by resistance is R2. So therefore VA value is equal to 0. What will it become? V2 divided by R2. So let's consider this as equation number 1, equation number 2. So from equation 1 and 2 we can compute the total current I. So the total current I is equal to I1 plus I2. So what is the value? V1 by R1 plus V2 by R2. Let's consider this as equation number 3. Now we designed the equation at the input end. Now let's design the equations at the output end. At output end, that is including from negative terminal VA towards the output voltage VO. So we are including the feedback circuit also. So the same current I will be flowing through it. So I is equal to, from where it is flowing, from VA towards VO. So VA minus VO. VO means output voltage, divided by what is the resistance in between them? RF, that is feedback resistance RF. We know the value of VA. VA value will be equal to VB value. VB value is 0. Therefore VA value is also 0. VA value, therefore VA value will also be equal to 0. Therefore minus V out or VO divided by RF will be left. Let's consider this as equation number 4. Since in equation number 3 and equation number 4, left hand side is equal, that is same current is flowing, so we can equate their right hand side. So therefore 3 equal to 4. Equation 3 equal to equation 4. What will it be? V1 by R1 plus V2 by R2 is equal to minus V out divided by RF. Now we need the value of output voltage VO. So we will send the minus and RF, that is feedback resistance, to left hand side. So the RF feedback resistance is in the denominator. When it goes to left hand side, it will be at the numerator. So what will be the final value? V out is equal to, when it goes to that side, it will be in the numerator. Therefore RF divided by R1 into V1 plus RF divided by R2 into V2 is the value. So negative, if it go that side, so negative. So this negative tells that the input is given to the negative terminal, that is inverting terminal of an operational amplifier. If we consider a case that if RF, that is feedback resistance, value equal to R1 resistance equal to R2. If R1 equal to R2 equal to feedback resistance RF, then what will be the value? Output voltage VO is equal to, if these two are equal, then they will cancel out each other. One will remain, 1 into V1 plus 1 into V2, that is minus V1 plus V2. So what is the value? V output is the sum of the input voltages. Output voltage is sum of input voltage. What this negative tells? Negative tells that the input is given to the negative terminal, that is inverting terminal of an operational amplifier. So this will produce the 180 degree phase shift. 180 degree phase shift. So hope you understood the concept. If you like the video, please subscribe and comment below. Thank you.